Morning students, welcome to the session on files. So we'll continue the session on files. So in this session we are going to discuss about file positioning or random access IO functions. File positioning or random access IO functions. See here there are three functions which are available, which are predefined in C language to perform random access IO operations on the files. They are fseek, ftell, rewind. Fseek function, ftell function, rewind function. So these three are the random access IO file functions. Right. So first one, fseek. So this function is used to move the file pointer from one position to the another position, either forward or backward. So coming to the syntax, so return type is integer, function name is fseek. So it is having three arguments. First argument is the file pointer, on which file we are performing file pointer. So every file is associated with the file pointer. So that is first argument. Second argument, number of bytes, that is of type long integer, right? Number of bytes to be moved. Number of bytes to be moved. Next, int origin. Origin means from which point it will move. From which point it will move. First one is the file pointer. Second one, num bytes. That represents number of bytes to be moved. Number of bytes to be moved from the origin. So origin is the position from where we have to move, from either starting position or from ending position or from the current position, that is. So here origin is one of the following macros. First, suppose beginning of the file, that can be indicated with the macro seek set. Seek set or a value 0. You can use anything. Suppose here you are specifying origin value at 0 or seek set means, so the file pointer can be moved from beginning of the file, beginning position of the file. So here you are specifying number of bytes to be moved from beginning, that is. Next, second one, from current position. If you want to move the file pointer from the current position, then seek current will be used. Seek current. Seek, S-C-U-R, seek current. So R a value 1. You can use anything, either seek CUR or 1 you can use. That means from current position. And third one, end of file. Suppose if you want to move the file pointer from end of the file, then you can use the macro seek end R a value 2. R a value 2. So here there are some examples. Fseek of FP 00, 0. This means, so where FP is the file pointer that is associated with the file. Next, 00 means from the beginning position. Number of bytes to be moved from the see here, this 0 represents beginning and 00 represents number of bytes to be moved from the beginning position. That means go to the beginning. Here, fseek of fp, 001. 1 means from current position. Suppose currently it is in some position, right? So from current position, so it will move to 0 bytes, means stay at current position. Stay at current position, that is the meaning. Coming to this, fseek of fp, 01, 2. 2 means from the end. From the end, it will move to the 1 character back. That means go to the end of file, pass the last character of the file. Pass the last character of the file. Or we can say from the end. So it will move to the last character. So pass the last character of the file. Right. Next, fseek. Fseek of fp, m, 0. So from the beginning, we can move the file pointer to m bytes forward. From 0th position to m bytes. For example, you see So file pointer initially points to this, right? So it is 0, index 1, 2 and so on. Suppose m value is 2. So from the current position, the file pointer is to be moved 2 bytes forward. 2 bytes means 1, 2. That means file pointer moved from here to here. Suppose you are specifying m value as 2, it will move from beginning to 0 indicates beginning to 2 bytes forward. That means m plus 1th byte. It is 2 means 1, 2, 3. M plus 1th byte means third byte. It points to the third byte. So that fseek of ft comma m comma 1. 1 means from current position, it forward m bytes. Suppose minus means backward. Plus means forward, minus means backward. So here from current position, it will move m bytes forward. So here from the end, it will move m bytes backward. So that is about fseek. So with the help of fseek, we will move the file pointer from one position to the another position. Next, ftell. So this returns the location of the current position of the file associated with the file pointer. It tells the position of the file pointer. Ftell tells the position of the file pointer. So whether it is at the beginning or it is at the end or it is at the middle. So that position it will tell. For example, file pointer is at the position. So here it is 0. So this is the file pointer. So 0, 1, 2, 3 and so on. Right? Suppose it is the end. Right? See here, suppose the file pointer is at the beginning, then it returns 0. Suppose it is at the end, it returns 4. Suppose file pointer is here, it returns 2. That is the location of the current position of the file pointer. So if a failure occurs, it returns -1. If a failure occurs, it returns -1. So this is the syntax for ftell. So return type is a long integer ftell of file pointer. Here we are giving file pointer as the input. So from this function, we will get the position of the file pointer. Right? So third function is rewind. Rewind means this function moves the file pointer position to the beginning. Suppose if it is at the end or it is at the middle. So from wherever it is, the file pointer can be moved to the beginning. That is a rewind. So rewind function moves the file position indicator to the start of the specified file. That is a rewind. Right? So syntax for this is return type is void, function name is rewind. So the argument is file pointer. It also clears the end of file and error flags associated with the file. End of file and error flags also be cleared with the help of this. Right? So coming to the program, so the demonstrate, fseek, ftell and rewind. So these are the random access IO functions. You see, first I am declaring a file pointer. Then with the help of file pointer, I am opening the file myfile.txt in W plus mode. W plus means reading and writing, right? So W plus mode. First, I am using fputs. Fputs function is used to put the string into the file. Here my string is, this is fseek, ftell, rewind demo using fputs. This is the string. I want to put the entire string into the file pointer. I want to put the entire string into the file myfile.txt. So using file pointer. So then after, so this is writing operation. I am writing the string into the file. Here the file pointer is associated with this file, myfile.txt. So these contents are written into this file. Right? So after performing write operation into the file, I am closing it. I am closing the file with the help of this function. Later, I am opening the same file. I am opening the same file in reading mode. R plus means both reading and writing. Now I am opening this file in the reading mode. Now the cursor position. So after opening the file in the reading mode, so the file pointer points to the first position of the file. So this is the first character of the file and this is the last character of the file. So on opening, the file pointer points to the 0. The file pointer points to the first character. File pointer points to the first character and its index is 0. Now the cursor position ftl of fp. ftl of fp. So ftl of fp, it returns 0. So the cursor position presently at the 0. Right? Position is 0. Position is 0. Character equal to f get c of fp. So what is the character which is in the current position? So here the file pointer points to the first character. Its character is t. T. So character is equal to t at the position 0. Right? F get c of fp means read the character from the file. So the file pointer points to this. Now I want to move the file pointer 6 bytes forward from the beginning. I want to move the file pointer 6 bytes. I want to move the file pointer 6 bytes forward from the beginning of the file. From the beginning of the file. For that, so first one fseek of fp. I want to move 6 bytes from where seek set or 0 from the beginning. I want to move the file pointer 6 bytes forward from the beginning. That is why seek set or you can use 0. So that means whenever this statement is executed, what will happen is the file pointer will be moved 6 bytes forward. That means 1, 2, 3, 4. Space is also treated as 1 byte. 4, 5, 6. Now the file pointer points to this one. File pointer points to yes, right? Right. Again, now the current position, cursor position, I want to know. I want to know the current cursor position. So ftl of fp. So ftl of fp, that means 0, 1, 2, 3, 4, 5, 6. So the cursor position is 6. Right? Next, its character is yes. So the character present at that position is yes. Next, rewind is executed. So whenever the rewind function is executed, what will happen is immediately the file pointer moved to the beginning of the file. Move to the beginning of the file. Again, the file pointer points to this position. File pointer points to this. That is rewind. Now I want to know the current cursor position. It is 0. After a rewind is executed, file pointer so points to the 0th position and its character is again. So now close it. So here I am demonstrating fseek, ftl, rewind. Okay. So these three are the random access IO functions. Now fread and fwrite. Fread and fwrite. So the read and write data types that are longer than 1 byte, the C file system provides two functions fread and fwrite. Fread and fwrite. So these functions allows the reading and writing of blocks of any type of data, right? If you want to read or write, so if you want to read the blocks of data, 2 or more bytes of data from the file, or if you want to write 2 or more blocks of data into the file, then we can use fread and fwrite. So fread is used for reading multiple blocks of data from the file. Fwrite is used for writing multiple blocks of data into the file. See here, this is the syntax for fread. C, size T, fread, void buffer. First argument is buffer. Second argument is the number of bytes. Third argument is count. Fourth argument is file pointer. In the similar way, fwrite syntax is, so it also takes 4 arguments. First one buffer, second one number of bytes, third one count, and fourth one is the file pointer. Right? So buffer. So from where, what is the source for taking the data? See, in case of fread, so we are reading the data from the file. So the data which can be read from this file will be stored into this buffer. How many number of bytes? Here we are specifying number of bytes to be transferred from file to the buffer is mentioned here, and right, that is number of bytes. Next, count. So count means, count represents, you see here, right, count represents how many number of items to be read, how many number of items to be read, that is. Second, fwrite. In this, so we are writing the data into the file, that is associated file pointer. So first we store the data into the buffer, that buffer data will be transferred to the file pointer. So this represents number of bytes to be written into the file, and count represents number of, count represents how many items are written into the file, how many items are written into the file, right? So this is, right, now coming to the program on fread and fwrite functions. So first I am creating a structure. Structure is employee structure, right? The variables of the structure are employee ID, employee name, employee address. There are 3 fields which are declared in employee structure: employee ID, name, address, right? Now I am declaring a file pointer, then declare employee variable. So EMP is the employee structure variable. Firstly, I am opening a file 1.b. It's a binary file 1.b in writing mode. WB nothing but, so open a binary file in writing mode. W means it's a text file. WB means binary file. So open this 1.b in writing mode. So I am opening it with the help of F4. So here printf, enter employee ID, name and address. So read the details of an employee from the keyboard, you know pretty well. So how to read the employee details? Here variable is EMP. So the employee ID of EMP can be accessed as emp.eid. Next, employee name can be reading as emp.name. Here emp.address. So in case of a string, you need not use ampersand. You may use or may not use. But here it is employee ID is of type integer, so you must use ampersand. So the members of structure can be accessed with the help of dot. So that first read the details of an employee from the keyboard. Now what I want to do is, I want to write the employee data into the file. After reading the employee details, first I am reading one employee details. So after reading those details from the keyboard, I want to write those details into the file. So here the buffer is EMP, ampersand EMP. So that is a star buffer we are using. So star means pointer. So pointer means it stores the address. So ampersand EMP. Then size of EMP. So number of bytes, size of EMP. Count is 1. Count is 1. And here the FP nothing but file pointer. So with the help of this, so the data which is taken from the keyboard for employee will be written into this file. Right? After that, close it. After that, close the file. Now I want to display the employee details from one.text. See so text file, right? See here fp equals, so first open it, open this file in binary reading mode. Open the binary file in reading mode, right? One.text, so in RB, right? Now with the help of fread, we can read the data from the file. So for that, ampersand emp, size of emp, so count is 1, 5 point. So here the employee buffer takes the input from the file pointer. That means, so the data will be extracted from file pointer into emp. So that is fread operation. Alright. Then those details, whatever the details read from the file, to be printed, to be displayed with the help of printf statement. So with the help of printf statement, we can display these values onto the console or monitor. So employee ID, employee name, employee address. So emp.eid, emp.name, emp.address. So all the details are reading from the file, then we will print it on the monitor. So finally we can close the file. Thank you.